In this video, I'll be showing you how to solve radical equations. A radical equation is just an equation that contains one or more radical expressions. So these are all radical equations that we're looking at here in problems 1 through 4. So let's go ahead and start solving these, and then we'll get into a little more detail. So on the first one, we have the square root of x is equal to 6. So I'm trying to get x by itself, and I've got the square root there that I need to get rid of. The opposite of taking a square root is squaring. And so that's how we're going to get rid of that radical. We'll square both sides. So when we square a square root, we know those are opposites, so we get x. And of course, 6 squared is 36. Now, this is a problem that you could have easily done just by looking at it. And it's certainly easy to check that square root of 36 does equal 6. But as we go along, things will get more difficult. So let's look at number 2 now. So now it's a little bit harder to see what the solution would be. Now, sometimes students will do this. The problem is we really don't know that we can mess with the 4, that plus 4 there, when it's under the radical. And in fact, we don't have any kind of rule that would allow us to do that. So we need to think about what we know that we can do, or we can get rid of that radical by squaring both sides, just like we just did on problem 1. So, oops, let's go ahead and do that. I'm sorry, I forgot to finish up problem 1. Okay, so on number 2 now, we're going to square both sides. And so when we square the square root of 3x plus 4, we're just going to get 3x plus 4. And of course, 5 squared is 25. So now we'll just solve this two-step equation. We're going to have to subtract 4 on each side. We get 3x is equal to 21. And then we'll divide each side by 7. Or you can do that one in your head. You're going to get x is equal to 7. So I just want to show you these are easy to check. If we plug in 7 for x into the equation, you have the square root of 21 plus 4. That's the square root of 25, and that does equal 5. And so x equals 7 is a good solution. Let's look at number 3. Now there's a couple of mistakes that students sometimes will make with these. Again, sometimes they'll try to combine the 4 and the negative 2 here, but I can't mess with the 4 because it's under the radical. The other thing is sometimes students will do this. They'll square each term. Now we are going to end up squaring both sides, but it turns out that this does not work. Like if you multiply both sides of an equation by 2, it's okay to distribute the 2 if there's 2 terms on one side. But squaring works differently than that. Let me erase this here. So if you had, for example, x plus 3 equals, I don't know, let's say square root of 5, and we, for whatever reason, we squared both sides. On the left side, you square the whole side, so this would be squared, and of course we would square the other side. And we already know that there's no rule of exponents for x plus 3 quantity squared. The only way we can simplify that is by multiplying 2x plus 3 out by foiling, and you end up with 3 terms. So you can't just square the x and square the 3. So all to say, we need to do something that we know we can do. We can't square each of the terms separately. It doesn't work. But what we could do is we could add 2 to both sides. That's definitely something we can do. We're left with the square root of x plus 4 equals 3. And now we're back to a problem like number 2. So I'll square both sides. We get x plus 4 is equal to 9. And if we subtract 4 on both sides, we get 5. And again, I'm going to go ahead and check the answer here. You can see that when you plug in 5 for x, we have the square root of 9 which is 3. 3 minus 2 equals 1. And so that is true. And so that's a good solution there. Now look at number 4. Let's go ahead and do the same thing. We're going to square both sides, and we get x equals 81. The problem here, though, is when we plug it in, notice the square root of 81 is not negative 9. In fact, if you look at this equation closely, when is the square root of a number ever negative? The smallest real number that I can take, or the smallest x value that I can take the square root of would be 0. The square root of 0 is 0. But we can't take the square root of a negative number because we end up with imaginary numbers. So no matter what we do, when we take the square root of a number, we're never negative. So right here in this step, I could have told you that there's no solution to this equation. And so this is something that we have to watch out for. In fact, with radical equations, when we have one radical, there's two main things we have to watch out for that are a little bit different. It's like we have a little twist in our equation solving skills. Number one, before we square both sides, we want to make sure we get the radical by itself like we did in number 3. And then the other thing is we need to check our answers. Now on number 4, it's pretty obvious, and you could see that from the beginning, but there are going to be other equations where it's not clear at all, and if you don't check your answers, you may miss getting, there may be some solutions that you have to throw out. So that's why I've been checking answers. So we've got steps to solve radical equations. So we said for, so let me finish up 5 here. Our solution on 5 is actually no solution. All right, so let's look at our steps for solving radical equations. So for equations that have just one radical, we're going to isolate the radical and we're going to square both sides, or it's possible that we could have a cube root and we would cube both sides. Remember, we want to keep in mind the rule of opposites. And then once we do that, we solve the equation. Now, with most of the equations we're doing, you'll stop at step 3 and you'll be able to solve it. If we have more than one radical in the equation, then we're going to end up using steps 4 and 5. All right, so let's continue on. We have some more equations in one radical. So on number 5, notice here we do have a cube root. So you should start by cubing both sides. You get 2x minus 4 on the left. Now, some of you might be thinking, but Mr. Smith, I didn't think the square root of a number could be negative. Well, that is true, but this is a cube root. And in fact, the cube root of a number can be negative. In fact, we'll see that here. We get negative 27 when we cube negative 3. Let's go ahead and add 4 to both sides, and then we'll need to divide by 2. We get negative 23 over 2. So let's go ahead and check this. I'm going to plug in negative 23 over 2. Now, notice the 2's cancel here, and you're left with negative 23 minus 4. That's going to be the cube root of negative 27. So we ask ourselves, what number cubed gives you negative 27? And of course, that would be negative 3. And so that is what we had here. And so this does check when you plug it in. And so this is a good answer. Let's move on to number 6. So again, we need to isolate the radical. Let's subtract 8 on both sides. And square root of a number equals a negative. There's not going to be a solution here. Now, let's say that you didn't notice that and you continued on. You'd square both sides. You get 2x plus 5 on the left and 36 on the right. We need to subtract 5 on both sides and then divide by 2. But don't forget, we need to check this. So 31 halves, we're going to plug it in, see if it works. And 2 times 31 halves, the 2's are going to cancel. You're left with the square root of 36, 31 plus 5. plus 8 equals 2. Well, the square root of 36 is 6, and 6 plus 8 certainly doesn't equal 2. So this is false, and again, we have no solution. Whoops, I'm getting ahead of myself here. All right, look at number 7 now. Notice the radical is all by itself, which is what we want when we have a single radical. So we're ready to go ahead and square both sides. Now be careful when you do this. The right side's pretty easy because you have opposites there. But on the left, we need to FOIL. We have to multiply out 2x minus 5s. So when you FOIL that out, you get x squared minus 5x plus 25. And if you combine those minus 5x terms, you're going to get x squared minus 10x plus 25. So on the left, I'm going to go ahead and plug that in. And on the right, we're going to get just x plus 7. So now notice this is a quadratic equation because of the x squared. And so with quadratic equations, normally we'll try to get 0 on one side and everything else on the other, and you want it in that form where you have the x squared term, then the x term, and then a constant. So let's go ahead and subtract x on both sides and 7 so that we get 0 on the right. Now a negative 10 and a negative 1x, you got a negative 11x there. 25 minus 7, you're going to get 18. And of course we have 0 on the other side. So we need two numbers that multiply to 18 and add to negative 11. Well, let's see. The factors of 18, we've got 1 and 18, 2 and 9, and 3 and 6. Now, since they multiply to 18, they're both positive 18. They're both positive, or they're both negative. So you can see that in order to add up to negative 11, they'd have to both be negative. Notice negative 2 and negative 9 are the numbers that work here. So let's go ahead and plug those in. We can do that because this is a 1 here. And let's see, we've got x equals 2 and x equals 9. So let's go ahead and check these and make sure our solutions are good. So if I plug in the 2, we have 2 minus 5 is equal to the square root of 2 plus 7. I'm just plugging 2 into the original equation. We get negative 3 is equal to the square root of 9, which is definitely not true. It should be positive 3. What if we plug in the 9? We're going to get 4 equals the square root of 16, and that's true. And so notice only the 9 works here. We have to discard or throw out the 2. All right, let's look at number 8. Now on number 8, notice there's one radical, so we're going to want to isolate the radical. We need to get rid of the 2. So let's add 2 to both sides. We get x plus 2 is equal to the square root of 5x plus 16. All right, so now we're ready to square both sides. So on the left, let's see, I'm going to have to multiply out x plus 2 times x plus 2, so I'm going to do that off to the side. So we're going to get x squared plus 2x plus 2x plus 4. And I can combine those two x's together. We end up with x squared plus 4x plus 4. And so we'll put that in on the left. Of course, we're squaring a square root on the right. We're just going to get 5x plus 16 there. And so now we're similar to where we were on number 7. We've got a quadratic equation here. We want to get 0 on one side. So I'm going to go ahead and subtract 5x on both sides and 16. You're going to get x squared minus x minus 12 equals 0. So this is one we can factor using the AC method. So we need two numbers that multiply to negative 12 and add to negative 1. So our factors are 1 and 12, 2 and 6, or 3 and 4. And these need to multiply to a negative, so they have opposite signs. And they add to a negative 1, so we want to make the bigger numbers negative. So notice 3 plus negative 4 is the one that adds up to negative 1. And so let's plug those numbers in. And so our solution is going to be x is negative 3 and 4. So again, let's go ahead and check our answers. That's part of working with, or when you solve radical equations, you need to check your answers. So if we plug in negative 3, we have negative 3 equals the square root of negative 15 plus 16. That's the square root of 1 minus 2. Negative 3 does not equal 1 minus 2. That would actually be negative 1, so this is false. Let's try the 4. So we get 4 is equal to the square root of 5 times 4 plus 16 minus 2. And so we get the square root of 36 minus 2. That's 6 minus 2, which does equal 4. And so it does check. So 4 is the only good answer there. We should eliminate the negative 3. All right, let's move on to number 9. Now, before we solve some equations that have two radicals, there's a little bit of review that we need to do with radicals. So if we multiply the square root of x times square root of x, in fact, you might even try to do a through f and just see if you remember how to do these. This is stuff that's you should have covered in your beginning or intermediate algebra classes. So square root of x times square root of x, you should get x. In fact, square root of x times itself, that's just the square root of x squared. And we already know those are opposites, and we just get x. Similarly, on b, square root of x plus 2 times square root of x plus 2, we just get x plus 2. Again, you could think of it as the square root of x plus 2 quantity squared. So again, those undo one another, you get x plus 2. Now on c, hopefully you said, I can't do anything there. You cannot distribute. So it's simplified as it is. 5 times the square root of x plus 2. There's nothing we can do with that. Now if you look at d, it says 2 square root of x plus 3 square root of x. It turns out that when you add radicals, you can only add like radicals. Not only do they have to be square roots, but they have to have the same number under the radical, or the same radicands. So these are like radicals. We add these just like terms. If I had 2x plus 3x, I would say that's 5x. In a similar way, if you have 2 square roots of x, and to that you add 3 square roots of x, you have a total of 5 square roots of x. So just remember, you can only add like radicals. So and by the way, I should probably mention this. When it comes to multiplication, normally if you had like square root of a times square root of b, that is equal to the square root of a times b. And so on c, we weren't able to multiply those together, the 5 and the x plus 2, because they weren't both under the radical. So if you have the square root of a number times the square root of another number, you can just multiply the radicands and you get the square root of that product. But when you're adding or subtracting, you can only add or subtract like terms. So if you look at e, you can see that these are both x square root of x minus 4 terms. So you're going to add 7 and negative 2, or just subtract. And so you're going to get 5 square roots of x minus 4. So 7 square roots of x minus 4 minus 2 square roots of x minus 4 give you 5 square roots of x minus 4. All right, so now we're ready to get serious with radicals and what we can and can't do here. We've got 5 minus the square root of x plus 2 quantity squared, all in parentheses, squared. So we're going to multiply 5 minus square root of x plus 2's. So this is a FOIL situation. 5 times 5, we're going to get 25. And then 5 times the minus square root of x plus 2 is minus 5 square root of x plus 2. Our inner product is also minus 5 square root of x plus 2. Notice we put the number out front and the radical goes second. And then a negative square root of x plus 2 times the negative square root of x plus 2 is just x plus 2. We know a negative times a negative is a positive, and square root of x plus 2 times square root of x plus 2 is just x plus 2. We actually did that in problem B. All right, so it looks complicated, but notice we have some like terms, 25 and 2, so we're going to get 27 there. And we have two like radicals here, minus 5 square root of x plus 2 and another minus 5 square root of x plus 2 gives you minus 10 square root of x plus 2. And then don't forget the x that's there. And so we get 27 minus 10 square root of x plus 2 plus x. Now on number 10, let's see, we have two radicals. So if you look back to our 5 steps, if there's two radicals, you want to get a radical on one side. And actually, I think I'm going to stop right here, and I'll finish this up in the next video.